Alright, now what I want to do is take you through the same data set that we did for the one-way ANOVA and show you how it looks in an SPSS output. Okay, so SPSS is the statistical package that we would use for analyzing the data. So if we did this analysis of this data through SPSS, here's what the output would end up looking like. And so you'll notice here things look pretty similar in our descriptive statistics to what we had before. We've got our means for each group, we've got our sample sizes for each group, we have standard deviations, and we have confidence intervals in that as well. We'll leave that alone for right now. Then we have the ANOVA table, and you'll notice this ANOVA table here is the same as what we created. We had in ours, we had a sum of squares of 48 and for the between groups, and 44 and 92. So this ANOVA table is exactly the same as what it is that we produced here. The only thing that's different is this bar column over here, what's called SIG on the top for the significance level. And so what this gives us, this allows us to not have to look up in the back of the book to find a cutoff score for the critical region. So when it says 0.004, that's telling us the exact probability of getting an F ratio this large by chance. Very unlikely. So in trying to think about whether or not something's statistically significant for making our decision, if we set our alpha at 0.05, if this is 0.05 or less, it's statistically significant. So it's nice easy way of looking at it, but it is different from what we were doing before with having a cutoff score and criterion region. So anything that's 0.05 or less in the significance column, we'd reject the null hypothesis, just like we did when we did this study by hand. And then down here we have our post hoc test. And actually here we have Chaffee's rather than we did Tukey's HSD when we did it by hand. And by the way, it's Chaffee's and not Chef's, so you know how to pronounce it. And so what we have here, we have a lot of redundant information in this post hoc test table. So we've got the Prozac group and the therapy group, and we're looking at the mean difference between these two. And so that'd be Prozac 5 minus 3 would give us this mean difference of 2. So we see our mean differences here, same thing with the Prozac and the placebo group and that mean difference. So that would be 5 minus 7, that's why we get the negative 2 number here. And so forth. So we've got this information, a lot of it redundant information. What we want to know is which of the groups are significantly different from each other. And there's a couple different ways in which we get the same information within here. One is that we have these asterisks here, and you'll notice here it says asterisk. If there's an asterisk, the mean difference is significant at the 0.05 level. So this is a nice, easy way of being able to just see, oh, there's an asterisk for this mean difference. That means therapy and placebo, there's a significant difference between those means. Okay, significant difference between placebo and therapy. Well, that's the same thing as what we had before. As I was telling you, there's a lot of redundant information. We'd also get that from this SIG column. You'll notice these are above 0.05 and above 0.05. Here we've got 0.004. That's below 0.05, and those are statistically significant. That gave us the same information as here. The third place where we could see it is in this 95% confidence interval. So this is a confidence interval for this mean difference. If this confidence interval doesn't cover 0, 0 would be the null hypothesis, right, for the mean difference. If it doesn't cover 0, then it would be statistically significant as well. We'll notice that the only ones where the mean difference, or the confidence interval doesn't cover 0 are for these statistically significant ones. The other ones where we've got a negative number and a positive number for these others. And those were not significant.